myself, Dr. Priti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So in this ongoing lecture series of ours, which is titled as Computer Networks, we are presently looking into the network layer, and in my previous lecture we have looked into so many functions of the network layer, and also how does this network layer actually works. And please recall that one of the very important functionalities of network layer is related to addressing. So this is going to be our today's agenda, that is network layer addressing. Now when we say network layer addressing, so this is basically the layer 3 network addressing, which is kind of we can say one of the major responsibilities, one of the major tasks of the network layer. Below this network layer we have a data link layer, which is going to which actually handles the addressing at the not at the network level, but at the kind of level of local machines, we can say, because that MAC address is handled by the data link layer. But here the address which we are talking about is actually the logical address, or we can say network addresses which we are discussing here are logical. Now why they are logical? Because these are actually software based addresses which can be changed by appropriate configurations. Now if we compare this with the MAC address, the MAC address is actually a hardware based or hardware encoded address. Now changing that is actually kind of very difficult and requires hardware kind of intricacies. Here the address is software based and we can easily change it by appropriate configuration, and this is actually a kind of mobile or we can say dynamic address. So these network addresses are logical. Now this network address, when we talk about, this points to what? This can point to a host, this can point to a node, or this can point to a server, or even it can represent a whole network. Now how it is possible that a kind of networking which is going to represent it could be a host, it could be a network, it could be a server, or the whole network also. So we will be looking into the class based addressing soon. So that is going to fulfill this agenda here. Now this basically, if we talk about this is also kind of as having a mapping with the MAC address, which is the hardware address or layer 2 address which I was talking about for layer 2 communication. So mapping between the network address, which is a logical address, and the hardware address is definitely there. Now when we talk about network addresses, how many network addresses or what different kinds of network addresses are in existence. So let us take a look. So different kinds of network addresses which are available or which are in existence are IP addressing, then we have IPX addressing, and we also have AppleTalk. And you all are aware that we have also mentioned this so many times in our this paper, that IP addressing is something which is being kind of used for this network layer. This is the prevalent addressing mechanism, because IP addressing provides mechanism to differentiate between the host and the network. They are the addresses which are assigned in an hierarchical manner. That means a host always resides under a specific network. We will be looking into the examples of it, and the host which needs to communicate outside its subnet needs to know the destination network address where actually the data or kind of the packet is to be transmitted. So a host resides under a specific network, and if it wants to communicate to a particular node or to a particular machine which is placed outside the network, then it must know the whole destination network address, that where that packet or where that data has to be kind of sent. Now host, if we talk about in different sub networks, needs a mechanism, definitely needs a mechanism to locate each other. Now, who is going to perform this task of kind of locating the host inside the subnetwork, or with the help of which particular facility we are going to do this. So, this task is basically done by DNS, domain name system, basically, or domain name server. We can say DNS, it is a server which provides layer 3 addresses of the remote host mapped with its domain name. So, layer 3 addresses of all the hosts which are kind of remotely located or located outside the outside the own network, they are mapped with its domain name, and this mapping is actually provided by your domain name server. And when a host acquires the layer 3 address, or we can say IP address of the remote host using this DNS facility, it is going to forward to all its packet to the gateway. And now please recall that the gateway is an internetworking element which is kind of in connection between two different types of networks, or between two networks which are working on different protocol. Or simply we can also say, because here the forwarding of these packets is done onto the gateway, we can also say that it is kind of a router which is equipped with all the information that leads to route the packets to the destination host basically. Now, router, how it is going to kind of send or transmit the data to the designated destination. So, this whole process is actually known as routing, which is kind of an method to reach the network, or method to reach the destination in an optimal manner. Now, why I am saying this optimal manner, I will just tell you in a short while. So, router, they are going to take help of the routing tables. Now, what these routing tables, if I am saying, then what all information is being kind of provided by these routing information. So, some some information like what is the method to reach the network, that is something which is provided by routing table. Then routers, upon receiving a forward request, forward the packet to its next hop. Next hop, that means the adjacent router towards the direction, or towards the destination, or in the direction of the destination. Then this process is actually, we can say kind of replicated. The next router on the path follows the same thing, and eventually the data packet is going to reach to its destination by, we can say kind of taking hops, whatever hops are required. Now, network addresses, if we talk about, can be any one of the following. Network address can be of unicast type, network address can be of multicast type, it can be of broadcast type, or it can be of anycast types. So, the four basic kind of types of network addresses are unicast, multicast, broadcast, and anycast. So, if we talk about unicast, so unicast is, as the name indicates, unicast, it is destined to one host only. Then the next one which we have is multicast. Multicast is, as the name indicates, multi, the term here which is kind of used is multi, that means the packet or the data is destined for a particular group. Then if we say broadcast, broadcast is something which is or it is a mechanism in which the data or the packet is destined for all. And if we say anycast, which is the fourth one, that means the packet or the data is destined to the nearest one, whichever the nearest one. So, that is why anycast. And definitely we will be looking into how this unicast, multicast, broadcast, or anycast is going to take place. So, basically the router which is kind of available there for sending the data or sending the packet, it never forwards broadcast traffic by default. So, this is kind of, we can say it is a convention, or this is something which is going to happen, that a router never forwards broadcast traffic by default, Multicast traffic basically is going to receive a special treatment, as it is mostly kind of an a video stream or maybe an audio kind of a message with the highest priority. Anycast, if we talk about, is just similar to unicast, in which the packets are delivered to the nearest destination. When multiple destinations are available, we will be picking the nearest destination and your packets are delivered onto the nearest destination. That is what the anycast is. And if we talking about unicast, that means we are talking about a particular we can say machine or a particular host or a particular node on which the packet or the destinations are to be delivered. So, router is basically the internetworking element which is available on the network layer, and the job is to forward the packets, and a forwarding table is included, or we can say it is configured on every router. The router passes a packet by inspecting the header field. So, header field is going to contain the address, the destination address, and after inspection of the header field, this router is going to index that packet into the forwarding table using that header field value. So, header field value kind of we can say is being used or is stripped off, and using that header field value, your packets are being indexed into the forwarding table. Now, this forwarding table value matching to the header field value specifies the router's outgoing interface connection, basically to which the packet is to be forwarded. So, after indexing done in the forwarding table, the matching kind of we can say interface is going to be looked down, and when that matching interface is found, the outgoing interface connection is being we can say on that the packet is going to be sent or packet is going to be forwarded. A host is sometimes is also known as an end system because it only has one network connection. Now, if we talk about an interface, so interface is kind of a shell, or it's kind of a barrier between the host and the connection. As a result, we can say the host will only have one interface. So, sometimes host, as I told you, is also known as end system because only one network connection is available, and interface being the barrier between the host and the connection. Because of the result, host will have only one interface. Now, a router is going to differ from a host in that sense that it has two or more connections to it. Router forwards a datagram. The packet is also sent to kind of one of the links, while if we look into the job of the interface, it serves as the border between the router, or we can say the host, and the connection. And the router can have many interfaces. Host will have only one interface, and router can have many interfaces because for each of its links one interface is required. Each interface may transmit and receive IP packets, and IP needs each interface to have an address. So, in the whole addressing mechanism, we can say there is a special role and the importance of host as well as of the interface, and that too of the router. Now, how this host and the network, as I have told you that these IP addresses or these network addresses may be call out for an host, or it may call out for a particular network. Now, how this IP addressing is going to offer or is going to distinguish between the host and the networks. So, the hierarchy in which these IP addresses are issued, as I have already told you that IP addresses are issued in a hierarchical fashion. A host is always associated with a certain network. The host that needs to connect outside its subnet it must know the target network address. Host on separate subnet requires a means for locating one another, and this, as I have told you, is handled with the help of DNS, which is domain name server, a server that offer layer 3 addresses mapped to domain names, and the further thing is done with the help of the gateway. Now, moving further, if we try to look into the structure of IP addresses. Now, IP addresses, you all are aware that there are kind of, we can say, two versions of IP addresses. One is IPv4, which is version 4, and then which is followed by IPv6, which is version 6 addresses. So, here presently we are going to look into IPv4 addresses. So, what is this IPv4 address? We have used it kind of so many times. Let us try to see the whole structure and kind of mechanism and other different nuances of this IPv4 addresses. So, this IPv4 as V is like version here, an IPv4 address is a 32-bit address which uniquely and uniquely we can say defines the connection of a device to the internet, and this device can be a computer or a router or anything any other device it could be. Now, these IPv4 addresses are unique. That means they are unique in the sense that each address defines one and only one connection to the internet. More than one connections cannot have the same IP address. So, that means this IPv4 addresses are actually we can say these are unique addresses. Two devices or two connections on the internet can never have the same IP address at the same time. At the same time, that means at one point of time, let us say an address X is given to a machine A, and that machine, let us say, disconnects from the internet. Now, that address X is free. That address X at some another point of time T2 can be given to another machine B, but at the same time A and B both should not have this same address X. But now it is kind of, we can say, required in some scenarios. In some scenarios we need to use this strategy that an address may be assigned to a device for a particular time period, and then it is kind of taken away, and that the same IP address is assigned to another device. But again, the same thing goes on here as well, that one particular address at one particular point of time cannot be given to two addresses and two devices, and hence they are kind of, we can say, these are unique. Also, these are dynamic addresses. That means they keep on changing as the machines connect onto the internet and then disconnect onto the internet. So, these are kind of dynamic IP addresses, unlike your MAC addresses, which are kind of static. On the other hand, if a device operating at a network layer is having M connections to the internet, it needs to have M addresses. Now, which device I am talking about? Maybe a router or some such thing. A router is such a device which needs as many IP addresses as the number of ports there in ports are there in it. So, every device connected to a single port is going to have a different IP address. So, router needs as many as IP address as the number of ports onto it. Now, if we talk about these IPv4 addresses and their structure, so we need to look into what actually the address space or how this address space of IPv4 is being defined. So, a protocol such as IPv4 that define the addresses has an address space definitely. So, address space here is the total number of addresses used by a particular mechanism or particular strategy, or we can say maybe a particular protocol. So, an address space, the total pool or the total number of addresses used by the protocols. So when we talk about that how many different address spaces are going to be there. So IPv4 uses 32-bit addresses, which means the address space is 2 to the power 32, which is actually more than 4 billion, or precisely we can say this is 4294967296. Obviously this is a huge number. That means this much of connections or this much of devices can be connected to the internet. We can say theoretically yes, more than 4 billion devices could be connected to the internet, but I am saying theoretically. Why I am saying this? Because this is a case if there are no restrictions, but there are so many restrictions which we are going to look into now. Because of those restrictions, the actual number is much less because of these kind of restrictions which are imposed on the addresses. Now how this 2 to the power 32, or because this is a 32-bit address and every kind of place holder in that address space can have two combinations, either it is 0 or 1. So if a protocol, if we can say, uses n bits to define an address, the address space obviously is going to be 2 to the power n, because each bit can have two different values, one is 0, another one is n. And so because going by this logic, n bits can have 2 to the power n values, and if we say it is a 32-bit address, so 2 to the power 32 more than 4 billion. But that is, as I have told you, it is a theoretical figure. Now why this is a theoretical figure, that we will look into, but first of all let us see the prevalent notations in order to show this IPv4 addresses. So there are two prevalent notations, one is a binary notation, another one is a dotted decimal notations. So binary notation in this at the IPv4 address is displayed as 32 bits and each octet. So 4 octets of 4 octets makes 32 bits. So each octet is often referred to as 1 byte. So it is common to hear an IPv4 address referred to as either the 32-bit address or maybe a 4 byte address. Both are kind of the same thing. Now looking into an example of IPv4 address in a binary notation, here is an example which shows that 0111101, then 100101001 and 000111101, then 0000010. So basically octets, how many? 4 octets making 32 bits. So this is actually your kind of we can say the binary notation. If we looked into the dotted decimal notation, which is used to show the IP addresses, they are far more compact and easier to read, because binary numbers in any case are difficult. Large binary numbers, I am sure they are difficult to read and comprehend, or we can say even remember. Although we do not need to remember any internet address, but still if we kind of want to study them, it is much easier to comprehend a dotted decimal notation as compared to the binary notation. So this dotted decimal notation much more compact and easier to read. So these internet addresses which we talk about or which we generally refer to are usually written in decimal forms with a decimal point or dot separating the bytes. Now how this dotted decimal notation will look like? So I am just taking the example of the address which I have taken in binary. Corresponding address in the dotted decimal notation looks like 117.149.29.2 and let us look into a figure. So this is kind of these 4 different octets of binary numbers, and each octet when represented in decimal notation is going to give you this kind of a number. So, this is an example which says 128.11.3.31. So, both the kind of we can say notations are given here, the binary notation and the dotted decimal notation. So, both the notations are shown in this figure. Each byte octet is 8 bit and each number in the dotted decimal notation is going to be a value ranging from 0 to 255, because that is the possible thing which can be accommodated inside kind of 8 bits. Now, on the basis of this, we also need to look into the different types of addressing schemes, which is how this IPv4 addresses are being arranged into different schemes. The two types of schemes which we will be talking in our next lecture will be the classful addressing and the classless addressing. So, here in this talk, in this lecture, we looked into the network addressing and its nuances, how many types of network addressing can be there, who is going to perform which kind of functionality, what is the structure of IPv4, that we have also looked into. More on to this network addressing in my upcoming lecture. Here is a list of references which is being used for the preparation of this talk. I will see you in the next lecture. Till then, take care. Goodbye.